Alright guys, like I said in part 2, we're going to jump into more bearing problems. So for example 4, a ship leaves port at noon and heads due west, so perfectly west, at 20 knots or 20 nautical miles per hour, okay, same thing. At 2 p.m. the ship changes its course to a northwest bearing of 54. Find the ship's bearing and distance from the port of departure at 3 o'clock. Okay, so let's now sketch this out. So the first thing is he went west. Okay, so let's just say we start here and we go west. And how far? 20 knots, right? And for how long? It looks like I went for 2 hours if I left at noon and then he changed directions. So are we cool with writing that as a 40 nautical miles, right? So 20 times 2. At that point, he changed his directions. It said northwest, okay? So and that's written as a bearing. So because it's written as a bearing, I'm going to draw on these poles. Make sure. And then now I'm going to draw in a northwest line. And I'm going to put in a bearing of 54. So north to west, 54 degrees. Perfect. And then I want to know for how long. So it's at 2 o'clock and then at 3 o'clock it says it stopped. So this is still going the same speed. Nothing has changed. So this is now 20 nautical miles. And it says, I want to find the distance back to the port. Okay, so that's the first question. So we want to know the yellow. I'm going to put an X here. And let's solve for the yellow first, guys. Okie dokie. So there is no angles actually written inside except just that bearing. But I know this made a 90 degrees. So if I wanted to know all the way, I'm just going to go 90 plus 54. So 90 plus 54, 144 I get here. So I'm going to actually write that in to help me out. Now I have to figure out how should I do this. If I want to know that side, and this is an SAS triangle, right? SAS triangle. I have to know which law do I have to use. So in this one, I'm going to use the law of cosine. Okay, so setting it up, I need to know x side. So x squared equals 40 squared plus 20 squared minus 2 times 40 times 20 times cosine of the degree, which was 144 degrees. Plugging this guy in, double check, again, type this all in all at once. I got that to be about 3,294.43. And then I took the square root. I'm going to go hundredths to be about 57.40 nautical miles. Again, put a box around your answer or highlight or do something, especially on any assessment. So we answered the first part about finding the ship's distance. Now I need to find the bearing from the port of departure and then at 3 p.m. So what does that mean? From the port, guys. Right here is the port. That's where we started, and I want to connect it to the line of the 3 o'clock line, so the coming back one. So I need to know this guy right here. So for me, it's a little bit easier to figure out what are my directions. So I'm coming from the north and I'm going to the west, right? Now I just have to fill in the theta, the actual degree that I need to find. Well, I don't have any other angle in here that I could use alternate interior. So the issue I'm having, guys, is I don't know what this is. Once I find that out, I can just take that away from 90 because it makes a 90 degree at that bearing, and then I'll know the actual bearing, right? So let's then figure out what is that orange theta. So what should I use in this one? Well, I know an angle and I know its represented side, which we got 57.40. I think law of sine might be a little bit easier. So let's set it up as a law of sine. We got sine of 144 over its side, which was 57.40, is equal to sine of whatever you want to put in there. Okay, you can do sine of P for port over its side, which was 20. All right, I need you to pause me at this point and see if you get the same answer, okay? All right, so then I got angle P to be about 11.82. So to figure out, I'm going to put that guy in here as 11.82. I'm going to go 90 minus 11.82. And I got my bearing to be 78.18 degrees. Awesome. Alrighty, so let's do at least one more bearing. I'm thinking let's do this number 5 one. 2 lookout towers are 50 kilometers apart. Tower A is due west of Tower B. A roadway connects the 2 towers. A dinosaur is spotted from each of the towers. Oh no, a dinosaur! I feel like we're in Jurassic Park world right now. The bearing of the dinosaur from A is northeast with 43 degrees. The bearing of the dinosaur from Tower B is 58 northwest. Find the distance of the dinosaur to the roadway that connects the 2 towers. Okay, so let's draw this out. Tower A. Tower A is due west of Tower B. So A has to be on the west of B. So on the left side. Great. A roadway connects the 2 towers. Let's draw that in. A roadway. Bada bing, bada boom. Looks great. Now I spot a dinosaur from each of the towers. Use those fantastic Picasso skills. Look at that dinosaur. It's like a bronchiositis, right? The ones that eat grass. Mine looks like a faucet, though. This is not good. It literally looks like a faucet with a plate and like a table as the body. Oh, jeez, I need to work on those skills. Okay, so we spot him. And what is our bearings? Okay, so over here it says from A we have a northeast. Okay. So I'm going to draw in this line. It's a bearing, so I need to draw in my poles. North to east, okay, it makes sense. It's going to the right, and it said 43. Great. Then I also spot it from Tower B, and it was also given as a bearing, so I draw in my bearing, and I spot it at 58. Okay, perfect. And it did say from north to west, so that makes sense, right? North to the west. Fantastic. Okay. Find the distance of the dinosaur to the roadway. What? They didn't even see how far apart they are. Okay, but find the distance of the dinosaur to the roadway. That's this distance. I want him to go back to the road. So I want to know H. I know if I drew that vertically down, it makes that 90 degree. Okay. What else is going to help us here? I don't even know how far these towers apart. We've done like a balloon problem, hot air balloon with the houses on a street, but they told us they're like 1,000 feet apart or something. This one, okay, doesn't really help us. All it says is that the 2 lookout are 50 kilometers apart. How do I know where to put the 50? Are they both 25, 25? No, they're not. You guys know this. Okay, right? That means their total amount is 50. So let's make one of them 50 minus x, and the other one will just be x. Okay, but what else will help us out? I'm betting that we need to know some degrees on these triangles. So this guy right here, I bet we can find, right? So I can go 90 minus 43. I get a 47 degrees. Fantastic. So 47 goes in here. And then if I go 90 minus the other bearing, 58, I got a 32 degrees in here. Now we have two triangles. We have this purple triangle, and then let's go green. We have this green triangle. Both of them share the height, right? So now let's write up our two equations, setting them equal to each other because they're sharing that height. So from 47, the h side, and the only side that is known is 50 minus x, so I'm going to use tangent. Tangent of 47 is equal to opposite h over 50 minus x. That's my purple triangle, right? Green triangle, tangent of 32, opposite h over side x. That's my green triangle. I notice that they both have h's, so I'm going to cross multiply them, and then I'm going to set them equal to each other because they'll both be h. So I'm going to get now h is equal to 50 minus x. Notice that I put that in parentheses because it's not just one number, it is a binomial. And this one, x times tan of 32 is equal to h. Set both of these equal to each other. And then x times tan of 32. Distribute. So I'm going to get 50 tan of 47 minus x tan of 47, x tan of 32. Get the x's to one side, so I'm going to add the other one over, so I'll get 50 tan of 47 is equal to x tan 32 plus x tan 47. At this point, let's take out the x, factoring it out. So x tan of 32 plus x tan of 47. Divide both sides by that tan 32 plus tan 47. And you should be getting your answer for your x though. Okay, so when we divide, we should be getting a 31.59. I don't care about the x, right? That is not going to answer the question of how far apart is the dinosaur to the road. So do not stop here, guys. This is not your final answer. Pick one of the equations because they already h equals. Plug in that x value. For me, the right one looks easier. So I'm going to have 31.59 times tan of 32 is equal to my height, 31.59 tan 32, and I got the height, aka the distance, right, from the dinosaur to the road to be about 19.74 units, kilometers. That is an awful kilometers. Gotta end it on a good note. Put a box around your answer, circle it, do something so you know that is your final answer. All right, guys, that's the end. Super proud of you. We're going to practice with C6 in class. You guys got this, okay? Make sure you keep advocating for yourself.